decided to take a break from some super math heavy stuff to do some less math heavy stuff. Um, for a thing, for the Borderlands rocks, I worked on a quantized normal. Should be. And this allows me to basically facetize normals, which is cool. Trying a new layout that's more conducive to streaming, so I'm getting used to that. So then what we have in the quantized normals over here is we can set how many different normal angles we want. This is probably a bad idea. Let's do something like a cone. That'll read better. Okay. This is what a cone looks like. We're going to turn this up even more. And then a quantized cone. So then I can change the number of angles, basically, and it's like a quantized filter. Which is something like a paraboloid. And we can see the vertical angles affecting it more. So it's kind of cool. Are these in my library? Border, no. So I used it for the Borderland rocks to get this hatching to go in the right direction and like at more of a macro level. So each of these different planes, it kind of goes in the way that you would hatch it if you're an artist. So you can hatch based on normal angle or light angle. And then we can shift the hatch angle. And then we can change our light angle, which gives us more or less hatching. Because these shapes are really round for the most part, it kind of breaks them into planes. So you can see like this plane break. So, but when I was working on that, I realized that the method that I was using wasn't going to work, and so I scrapped it, and I wanted to come up with a way to use a palette so that you could do something like this procedurally and choose a limited number of colors. So I think this is a high-res texture pack in Minecraft. As you can see, there's a lot more detail in there. If you look for like default, something closer to default, get ray tracing. Looks more like this. So first, I want to make a pixelize effects map, basically, and then need to do a palette sampling thing. So nothing in it because it's basically just going to be this. Pixelize. Put this in my experiments. Pixelize looks weird. I think it should have two L's. Okay, so we're basically going to have one parameter, and that's going to be pixel size. Which is basically going to subdivide whatever size thing we have down. Should it be an integer? If pixel is a percentage, I'll just keep it like this for now. First thing we gotta do is give it a pattern, which is going to be a square, and we're basically going to change the color of the squares based on what's underneath that square. And then we're just going to do max, and then start at the top so that we can set our variables and then inherit them. So they'll go in here. So we're going to get pixel size. Actually, I don't know if we want that. We want to do, I made an integer, right? Yeah. I'm trying to think. We may want to do a percentage of the width that may work better. We'll see. So we basically want to grid it evenly, X and Y. So pixel size could be just dividing it. It's an integer of the number of divisions. Let's do that. So we're going to do the size will give us how many pixels, but this, we don't need that. The pattern width, okay, I'll take some steps back. Okay, so here we have our FX map, and we go inside, and in the quadrant we have our pattern size. Let me switch it to black and white so we can see. Okay. So the pattern size is a percentage already. So if I take this and I do to float and then both, and then we'll do so this will do 1 divided by the pixel size, which will give us the percentage of the whole width. And then we're going to set this as our pattern size. And then sequence it so we can set the color of our pattern. And then go down to our pattern size. And then get that float 2 that we just set. Pattern size. Set that as the output. And now it's taking up the whole screen, whole view. So then we go out here, change the pixel size. We're shrinking it. Cool. So 10, it's at 1/10 of the width. So then, to get enough pixels to cover the screen, we got to iterate through that. So if it's 1/10, we need 10 times 10, right? Trying to get that integer, which is our pixel size. And then we're dividing by that to get the relative size. And then it's square, so we're going to square it. So then the only way to really preview it is change the luminosity down. So it should get brighter as we turn this up. And it gets darker. Oh. One divided by, oh wait. Oh, it's just a square of the pixel size. There we go. So I'll go slower. Okay, so it starts out at 0, it's black, and it goes to that 0.1, and 0.2, 0.3. We got a bunch of stacks. Now we're at 1. Because it's squaring it, so. This would be 4 of them, so 0.4. Yeah. If we change this to 16. Then we get an actual 0.4. Okay, so we're getting the right number of them stacked, which is good. That math is bad. And then we need to gridify them. So we have their size, then we got to get their position. So we basically have to get which column and which row the pixel is in. So we're going to swizzle this off. Keep that there. So here's our columns and then rows. So if we take one, pixel shrinks currently. So the number of columns is based on this. So this is the spacing. These are going to be equal, so I don't need to like swizzle them off. It's going to be in the first row if its number is divided by this value. So I don't need to swizzle. So if its number evenly divides by this, then it's still in the first row. So then this gives me the remainder. So I'm going to take the number, divide it by that, subtract the remainder, which will give us that even row number. And then multiply it by this number. So that should be our Y position. Let's comment that. So this should be our row. Because the row will go up once we get to, say, 8 with the size of 4. And then the remainder is the column. So X, no, swaps. Row is the Y, column is the X. We'll set. This is our pattern offset. We could save a sequence node by using a swizzle here, but it doesn't really matter. And then we do the get out here, pattern offset, get flip 2, pattern offset, set as output, and see if we did it correctly. Yay! Since the pattern size, it's filling out this grid, we're just going to do it basically luminance by pattern number. And did it incorrectly. That's not correct. Oh, gotta add the offset, because we'll just do this. 0, 0 is in the middle. So in order to get it to start in the top left corner, like that, we have to, and if we center it, then it's sitting at the center of this square in the corner, so we basically have to add half the width and half the height to it. So we're going to multiply the size here. Actually, yeah, we'll just do that. Because multiplication, you can multiply same types. So this is half the width. And then we have to start at 0.5, 0.5. Oh, negative up here. So then we take that as our starting point. And then we add half the width. And that should give us a more correct. So it's sitting in the top left. It's then going incorrectly on the sizing. You can see it's getting barely offset. So I messed up the math. So let's take a look. We got the pixel size, which is 10. So then the number divided by 10, subtracting the remainder. So at 0, it is 0. 0 divided by 10 is 0. The remainder of 0 divided by 10 is 0. So it should be top left. Let's do 1 minus just to make sure. Yeah, we're getting some overlapping. Okay. At 1, it's 1 divided by 10, which is 0.1. The remainder is 0.1. Subtract that out. Gets 0. So then 0 times whatever we're multiplying it by, the size, is 0. So it should stay across the top. But it's dropping down. Huh, okay. I could floor it. Let's see if that works. That might be what I should be using. Okay. I gotta make sure that I'm like rounding it down to an integer. So now, okay. So see how things kind of go down by about 0.1 every time. So then I use the floor to get rid of that decimal. So then it's getting brighter, and it gets bright to here, and then it's not working the way that we want it to. So to get the column, it's gotta multiply by, wait, they're offsetting correctly. and use this to test. So we basically have 100. So if we go 0.01, this would let us know if anything's overlapping. It doesn't look like anything's overlapping. So then our color is weird. So it should be our pixel size, which is 10. 10 squared is 100. Oh, guys, because it's not 1 divided by 100. And then the number times that. Not sure what this dark. One divided by 100 should be looking at the number down there. If you round it, it's 0.1. And then so I could do by row number. The row is falling off early, it looks like. So column looks correct. Which is a gradient that goes across. This number should be different. It should be 10. So then if we switch this, ten, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. I mean, this will be number 10, but it's 10. 10 divided by 10 is 1. 4 to 1 minus the remainder, which is 0. I'm doing my math incorrectly. This should be returning the remainder. I don't need to do that. Okay. Oh, that makes sense. Okay. So, reason this was causing an issue. I'm flooring it and then subtracting what should be the remainder. But, yeah. So I'm basically double subtracting. So I believe it should be like that. Yay! Okay. So the value of this is 0.09, and this should be 0.1, which it almost is. 1, 1, 1, 2, 3, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, 2, 2, 2. Yay! Okay, so it's getting brighter as it goes. Perfect. So we don't need to do that. We can just say everything's white. Save. So this is basically like pixelizing the whole thing based on our pixel size. The pixel size relationship is a little bit weird right now because you're choosing like how many pixels, which you don't necessarily want, but that's not terrible. Um, so then I'm just going to use like a clouds, put this in here. So then we want to pixelize this clouds by sampling the color. So we're going to take our pattern offset. We're going to do sample gray for now because we're working grayscale. And I want to sample based on where the center of that pixel is. And now we get a pixelized image. And I don't think... Cool. So the way that sequences work, if the calculation of things upstream isn't required, then you need it. So we'll do this. Okay. So if I remove this sequence, then I stop getting this pattern offset because it didn't go to this chain as part of this calculation. It did pixel size, some math, these lines aren't connected at all to the output. So then if we do this, then it goes, oh, okay, and then it includes all this stuff. But here, if we set this as the output, we don't need these sequence nodes because you can see that all these lines are connected somehow to the output. So we have our pattern size that goes into here, which is used here, which then gets set to our pattern offset, which is then used to sample the grayscale value. So you don't have to use those sequence nodes because everything, all these lines lead to the end and they're all connected, which is nice, makes it a little easier to work with. So as long as we make sure that all the lines somehow connect to the end, whatever the output is, in this case, the color, because we are working in this function, the color function, we're good. So we can pixelize this further by, let's add a max on this. Do we need to? Let's just let it go up a little higher. Okay, so then we're basically pixelizing this image. Now it's not doing anything fancy, it's not like sampling nearby ones, it's just wherever that square lands. So like this square here landed on that value pixel. So it blends it out. We could use like a directional blur, do kind of a Sobel type thing if we wanted. The intensity needs to be based on pixel size, but so we could do something like this and sample both of them, and then like average. We'd want to do all three. And there's a weight to it. They're weighted averages. think it's 0.3. I think, but this is 0.3 and this is 0.3. Let's find out. It is 0.25. So this is there's so many different matrix convolve weights. And the more accurate one, it is 8, 2. 2 is quarter. Yeah, so it's the same. So then we wanted to do that. Not that one. No. That's not exactly correct, but doesn't really change it that much. The blur amount probably need to change. There we go. Pixels change a bit. We're basically just going to do a nearest for now. I could. Okay, so then if we were to give this a color input, switch it over to color. Could have kept the clouds. I don't know what this is, but we'll just throw it in there. It's getting some weird alpha. I don't want alpha in there. Oh, that's why. Ha! There we go. Okay, so that's cool. But what it's doing is it's just putting the pixel down and going straight behind it and hitting the texture. So any sort of interesting color variation that was added to make the texture look good. In here. So there's like a little bit of purple. There's like this really golden color. There's like teal. We don't have any palletizing going on, which is really important to this kind of look, is that you need the really limited color range so that the grass up here is all following the same thing. The sand is using 6 or 8 colors, so then across the game you have 256 colors, as opposed to this, which is just simulated blurriness to kind of make it feel similar to this, but it's not actually a palette of colors. So we need a way to palletize this based on a color set. So we'll use, maybe not this graph, a new graph. I'm going to create a palette. Which is going to use basically this, but with some hard-coded values. So the size of this graph, we're just going to make 16 by 16, because that gives us 256 colors. For a palette, I can't think of really needing more than that. And then we're going to give it a bunch of inputs. And I probably should give these names and stuff now so I don't have to do it later, but what is that? 1, 2, 3, 4, 5, 6. I have to go to at least 8. Make sure they're not plugged in the background. Okay. So our iterate, the pixel size is 16. So currently we're sampling, but we're actually going to be doing a switch. So we should still get the same grid of patternness. 10, 1. Isn't my background black and transparent? I'm trying to figure out why it's going to white on add sub. Anyway, okay. It's going to be the input image. And then we're going to switch between these based on the number. and we'll wrap. No, we don't want to do that. In order to keep your color from getting messed up, you basically have the color luminosity and color mode. If you're giving it a color, is a multiplier. So set. We don't want to mess with it, so we're going to keep it at 1 on everything. So whatever we get, we send. Okay. There's no way for us to really test this without just trying to use the node. Yeah, I really should just set this up. Okay. So I'm going to use this MIP trick to crush whatever color they give me. Just turn it to whatever the average is. So if they're not giving like a solid color the way that they should, just figure out whatever the average is. Then usage is any. Yeah, it should be given an input, I think. Oh, yuck. We're just going to format it that way. Or match the identifier in the name. Even though the index is 0 based, we'll just name it based on what this is. So that when we duplicate this, we don't have to change the identifier here. We just have to change the number. So I would probably want to put this into another thing. So make groups of 4. 4 by 4, and then 4 by 4 of that would get the 16 by 16. So if I do 16 inputs into this, this should be 8, because this is 7. Should be 15 because it starts at 0. So then this is 4 by 4. So I want to change my iterate here to 4 by 4. Change it here. So we're basically doing a sub palette. So save this. So if we bring create palette in, and I need to fix the names eventually, but moment of truth. Yeah. So we're building our palette. I don't like how these edges get blurry. So we're going to change this to just nearest so it doesn't do weirdness as much as possible. But it's basically blowing up this tiny thumbnail into a larger node thumbnail, so it's fine. It's kind of hard to just sample 16 logical random colors. Definitely feel myself gravitating toward certain ones. See it? Yeah. So if I do a create palette again, I could plug each of these in. The problem is that the MIP MIPs it down to the average color. So should add a parameter for that. Let's make it a Boolean and do default is true. Should have done this before. If we do if we just switch it between automatic and manual, I believe that will do it. Oh, I can't do that. I could do to float to integer, I guess. Okay, so the first one's good. The second one is still getting mipped, so I gotta hook that up for all of them. So all this stuff. I want to copy that. I wish I could like insert this. No, can't shake it in. I'm holding shift to move the connections. Since it would create an infinite loop to hook the output here back to this, it prevents that. So I can move these connections, the in and the out, to the out, and then it fixes the thing so it causes an infinite loop. So I just drag this over, hold shift on this connection, move it to there. So it makes it a little easier to fix the mistakes. So then everything should still be hooked to where it should be, but now I have this switching bit in between. Okay. Come back over here. Yay! And then mipped, not mipped, mipped, not mipped. $256 colors. So I guess you don't have to use an enormous palette if you don't want to. You could use a 16 color palette or more, I guess. If you don't plug colors in, then it just goes to the default, which in this case is the background, which is black and transparent. So you could have a smaller palette. The way that we'll build it, you could have a smaller palette, and you'll just basically have duplicate colors that will sample multiple times, but you should find the same result. So not maximizing the palette will be a little bit slower to calculate, but it should still function. Well, it'll be the same to calculate, and it will work without it. Yes. So then we need a way to sample from the palette and spit out the color that is the closest. With 256 colors, that means I need 255 if checks. Which is a lot. I'm just thinking about that graph. Seems pretty large, so we're going to do it's probably not a word, palletize. It's going to be a pixel processor, which is going to take a palette. Just going to grab this one so we can see what we're doing. So the palletize is going to go after, no, it'll go before the pixelize. So first, we give it the image and then the palette. So we need to get the position of the pixel that we're sampling, and then sample, it'll be color. So we need to sample the color of the input image, and then we need to sample basically all the different palette sections, which is hard-coded-ish. But we could be giving it a 16 by 16 or a 4 by 4. So we do need to tell it the palette dimensions. We're going to start small. We're going to start by hard coding in a few positions that we know are good, and then we'll go from there and figure out a way to get it to work. 0.25 would be right on the line between, wait, let's take a look. So 0.25, yeah, is right on that line. So we want to go in from that halfway. And then the next one, we're just going to do this. We're going to add that on for the next one. And then so I'll just offset it and then go down this way. So the first thing we're passing in is the image, and so this one's going to be 1. Okay, so that should get us 4 samples, currently just across the top row. And the reason we can't do like a gradient dynamic, well, we could, but this doesn't palette, it doesn't find the closest color optically to the input image. All it's doing is remapping based on value across this. So it just samples, shoot, and then maps based on value. We don't have any black or almost no black in this image, so there's almost no black here, even though that might be closer. If we just move down, then we hit the next one, we see there's the same weight here. So we don't want to be doing a gradient dynamic. It'd be much easier if you want to make your own gradient dynamic. It is this. So we grab the position of pixel, we sample the grayscale value, we're going to treat that as the x-coordinate. We're going to have a offset basically. Vertically. So we could do bilinear, which is more similar, I think. So then we can move down the palette. If we want to go the other way, which is basically the drop down, right? Vertical versus horizontal. So then we could go vertical instead. Horizontal, vertical. It's a gradient dynamic. So right now we're sampling across here. Don't do that, just use their built-in gradient dynamic, because it's an atomic node, so it's almost always going to be faster. Okay. So then I made some color utilities. There's the idea of optical similarity, which is delta E. Just post the Wikipedia link in here. So the delta E is how close two colors are, and you have to get basically the distance in 3D space between those 2 points. So in order to get their distance in 3D space, we have to be using a 3D color space, which lab is, which is what the delta E relies on. So I've already made some stuff, and this is the stuff that I tried to use in the quantized normals, but it doesn't work because with the normals we want the math versus the optical similarity. So we're going to convert RGB to XYZ. Should be here. And then this, I believe this is sRGB. And I can't remember the reference. I should just make a reference for this to convert between the different colors. So this is the weights for sRGB. And then got to convert this. So this is our reference color. And then delta E. So we take this one and that one. I believe it has a default weight in it. Yes. So if you don't give it a weight, it has a default weight. So this is going to give the delta between this input color and this palette color. So then we basically need the minimum, the one that has the smallest delta of all of these. And then we need to check to see which one is which. So if this delta E is equal to the minimum, then it's this color. If this delta E is equal to the minimum, then it's this color. If this delta E is equal to the minimum, then it is this color. Really, we should check, but we can assume that this last, if it's not any of these other ones, then it's the last one. And then just hook these up to the chain. And then that's the color. So we're sampling diagonally across here. If you wanted to sample horizontally, just straight across. So we're going to pick some colors across here. So this is our gradient, and then according to what the palette that we have, these are the colors that are closest in every pixel on this image of 4 colors of the 16 colors we have available. Oh, okay, cool. Graph view. Graph. So then all we need to do is sample all 16, and that is basically this for each one, which makes me want to figure out a way to do it more procedurally instead of hard coding these locations in. So the other thing The other thing we could do would be to put the pixelize and palletize together. So we could have the FX map assume a white input and then just sample from the input that you gave it, and then shift the color to be equal to the palette match. And then instead of sampling every pixel, we only sample the ones that we care about when we pixelize it. So then this would get, I'm just going to pass it this by default. Take these, because then we can give it a parameter of the things, and it can sample each of those. So you can shift this color, because currently it's inheriting it from the thing that it's sampling. So instead, we can have it sample that point, get the color, and then figure out the delta E for all the palette locations based on the palette input number, because then it can sample through all the different points. So then for each pixel, we're sampling the number of palette colors. So that's number of palette colors, or I guess number of pixels to the number of palette colors samples, which is a little intensive and definitely not something that you'd want to be running in real time, but it should be okay for like pre-calc stuff. So this offsetting is almost exactly what we have to do for all the other samples, but we only have to sample from one input. Which I think I want to make into a function so that we can edit it more easily and we'll have less stuff flying around in the graph. So we're going to assume that the palette is on a grid because you're using the other palette nodes. So we could square root it. Ah, so tricky. Okay, okay. So this is our sizing. So then we basically need to take uh, um, so this is going to give us basically our increment along the width, and then we need to, just like the grid, we need to offset by half the width so that we hit in the middle of the palette tile rather than on the edge, because then it's just going to give us a one or the other, which we're not sure which based on that pixel, or it's going to give us some blurry smudged average based on the bilinear filtering. So then this will give us, for example, 0.25, and then we multiply it, and then this is trying to figure out a way to like make this extensible to 256 colors without hard coding everything. This is basically a for loop inside of a for loop, because the pixelize is going basically in that grid, and then for each one of those grid elements we need to get all the colors. I haven't really used the value processor. How many outputs can this have? One? It can only have one output of a float 4 or lower. And I need potentially 256 values. Unless I do something weird with like hex encoding binary coloredness. It's not gonna work. Okay. Oh, this has to have, because we have sample colors, you can't sample color inside of a function. Because it doesn't know which color, I think. Say 1. Let's see if we can put this function inside this pixel. No, sorry, this FX map. see if it outputs anything useful. Should be this, but it's not. Okay, so I can't actually put it in a function because I have to sample colors, which I have multiple inputs, so I can't choose the correct color to sample. So there's just going to be a mess down here, which is fine. This is going to be our palette size. Currently, it is 4 by 4. You'll still be able to kind of duplicate. I need to get the rows and columns the same way that I did up here. So but then not the number. I'll have to give it a number for each one, which will make it a little bit easier. Okay. So row, we multiply it by the size of the thing, size of the palette, and this is our add a half to it, and then mod. This is going to be my own palette tracking number. Starts at 0. Divided by this. And then multiply by the size. And then also add so this should be number 0. This I could turn into a function where I give it a number and grid info, and then it gives me the row and column of that. And I don't have that as a function in my library right now. So that seems super useful. So I'm going to put that in this function. So we need number. This is a float. And then we need float 2 of xy. So then we get our float 2 of our xy. Such math. And then we get our number float. So that's number. This is 1. Yeah. X. To make this extensible to other things. So this is our row, and this is our column. And then this is adding half the width. So then if we want that and we want it to work with everything, then we need our size xy. So that we could use it for other stuffs. Row is y. So then whatever the size of it is, offset it. Let's see if that works the same way. Oh, should rename this. It's column row, because that's xy. Okay. So, in theory, I should be able to give this 0. I should be able to replace all this. So I give it a number. I give it pattern size. And then the number xy is the same. So then this should be able to just go here and not break. What's weird is it changed a little bit. Like all the squares are essentially in the same position. I guess the math is slightly different. I wish function graphs had a clean. Do I need this, do I need this, do I need this, do I need this? Do I need this, do I need this? Do I need this? So I'd be giving it a different number xy. Um, oh, it starts with black, so that's why. Hey, all right. That's basically scrolling through the swaps or the palette items. Is it doing it properly? Okay. Black? Oh, it's going down. It's going all over the place. Well, that column row thing is not working the way that it should. So we have our number. Should get the... This is our row. Which then gets multiplied by the number y to move it down. And then the leftover gets moved along x for the column. And then we add half the height, basically, and half the width. And this goes in the y component, because that's the row. And then this goes in the x component, because it's the column. We don't need the y for the column row, because says goes across, and it's like, oh, I'm still in the first row because I have no remainder, or I'm not past the number of x. So I'm first row, and then once I get to 5, then move to the next row, and then get the remainder, and that's the column. I think this math is correct. Maybe this is messing it up. Oh, ha. It's the offsetting portion. So it's not starting in the top right. So both of these are wrong because it doesn't offset it based on the starting point, the known starting point. Which I should probably build into this. This is basically the offset, and then I gotta add to get to the top left corner. Alright, let's make sure this looks roughly correct. Why is it starting on yellow? It's kind of jumping around oddly. Anyway, okay. Let's just assume that this is working. That's the beauty of the function, is that we can fix it and it will work. So we're getting one giant thing centered that's sampling in the middle, which it shouldn't do, but that's okay. So I should be able to basically duplicate this So I have some weird math happening in here that is not working the way that it should, but so then I move this. So once it's sampling from the correct location, these will behave the way that they're supposed to. Should just line these up. And I should make them decrease in value as they move down. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is 0, 1, 2, 3, 4. Are you guys following along? Totally lost? Have any questions about this insanity? Probably tuned in to see me do some art, and I'm just doing math. I feel like I missed something. I messed up. 6, 7, 8, 9, 10, 11, 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 0, 1, 2, 3, 4, 5, 6, 7, 8. I put this on share. I get it to a point where it's good. I did it again. 10, 12, 11, 12, 13, 14, 15. Okay. So this is going to sample all the colors of a 16 color palette. I should have put in all the other stuff. This stuff. This part's not very fun. Yuck. Maybe all of this will only support 16. I don't know. Now I gotta make a min chain. So that we can get the minimum delta, then choose that color. When the number of mins is like the total number of inputs minus 1. And then we have an if for each one, minus 1. The calculation time on this is going to be kind of absurd. But it will be cheaper / faster than a pixel processor, I think. Because you'd have to do this for each pixel as opposed to each instance of your pixel that you have for the FX map. Oh, that's double. Like this. All right. Min, 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 min. Find the min, find the min, find the min, find the min. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, we got the right number. Now we just have to check to see if that delta E is equal to the min for all these. Easy peasy. It'd be a lot nicer if you could just use a selector of some kind, something that says, I'm going to give you a bunch of stuff and give me the one that matches the other input that I gave you. Oops. Let's make sure I'm replacing the right one. Top one. Top one. Top one. Top one. Top one. Top. 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 And then we'll see we'll see how this works. For all this work. I mean, I know it's not going to work because my row column function isn't working. But we'll see if it works in theory given the things that the row column actually returns. Trying to make sure I don't get my wires all crossed. Looks correct. I also wish there was a like a sorting matrix kind of thing. There you have it. Done. It pixelizes and palletizes the stuffs. Consistently, the top right one is red. Okay, it's not. So out of curiosity, we can go in here, set this. So it's purple before, and now it's purple still, which is excellent. Any of the colors that exist in the palette should also come out the other end. Assuming that color actually gets sampled with the broken row column thing. But since this gradient editor came out of the palette, it should. Okay, so it looks like the row column thing isn't sampling all the colors. So we'll see if that gets fixed. We should end up with a pixely version of these 4 colors when we fix it coming out of here. We'll go back in here. This column row, let's open in context. Let's just go through it. So the parameters that we have in here, it's like what's the index. I'm going to switch this to index. What's the index that we're given? And then how many are there in XY? Which really this should be an integer too, but I don't want yeah, it should be integer too. So then we'll go back in here. This stuff's all broken. That's fine, because we should be able to do this. And that should fix it. Oh, yuck. Oh, because I changed an identifier. Don't do that. We have all your stuff connected. Don't change an identifier. That's especially when you're doing something like this. Good thing I didn't set it up for 256. That would have been quite the mistake. Okay, back over here. So how many are there in the xy? We're going to take 100% 1, and we're going to divide it by that number so that we get an increment, in this case 0.25, in for each one. So as far as a pixel processor would be concerned, or this even, it starts at 0, index being 0, 0 divided by 4 is 0. Okay, index of 1, 1 divided by 4 is 0.25. So the column width, row height should be 0.25. That's what we want. And then this is add half the width. Perhaps I take that out for now, just to see. That totally broke it. That should not break it at all. That should just make it work slightly differently. So that's offset it a little bit. It's exactly what we want. To, oh no, vector int 2. This is giving me the pattern size the same way that is. So these colors should be like exact, right? It should be precisely those colors. So we should come up with just a pixelized version of exactly what this is. It's not what we get. So we should get teal, magenta, orange, and I guess cyan, and then a teal at the end. We don't. we get like white down here, which these shouldn't be closer. So then that means our sampling is incorrect. This row columnness. So we're just going to troubleshoot and check and make sure this stuff's correct. So input 1 is where a palette goes, input 0 is where the input image goes. So 0, that's our input, 1 is our palette. Based on the palette rules stuff, the row columnness that I set up, it should go black at 0, this green at 1, purple at 2, this green at 3. So it's going pink at 3, or at 2. Black should be 0. 0, cast to float. It's a 4x4 with the size being based on that as well. So our row columnness is not working. So what did I mess up? That's going down. Like back over. These are wrong. Dang it. Trying to figure this out and it's just being weird. So black, perfect. Just, no. Should go this way. 0, 1. So at 1, it's 1 divided by 4, which is I mean, we could stay with integers. And then not have to deal with the whole floor thing. So take the x out, turn this to an integer, do index divided by that doesn't do anything. So this part is functioning. Since everything is a grid, I could get rid of the x part and just tie everything to that one size. And black still, not black. could just hard code. Should be black. That should be this pink. Should be green. That should be right here. I'm so stumped. Because I'm just setting this as the output. We just like sample color, float 2. We're going to go down 0.125 so we're not skimming across the top. And then same exact result. 0.625. 0, 0 is black. Should be pink. Okay. Should be here. I was thinking that it might be because the scale of these are different. It doesn't look like it. I am so stumped. Just gonna trying to like recreate the same kind of scenario, and I'm getting all the colors that I think I would be getting. So if I go just a little bit in and then down a little bit, I should be hitting reddish. Okay, this is working. Oh my gosh. Blending mode. Ugh. There's something weird happening. See this like double line thing? So that's weird. Some weird glitch there. But the real reason it wasn't working is because the blending mode, so it was doing some weird blending on the sampled color. I think. We're gonna check. And then fix the column row. Make sure that we're offsetting correctly. So this is sampled from the palette. Okay, so the position stuff is wrong on this column row. I'm getting the right colors now. which is good. Ah. The calculation that's coming out is not evaluating as equal. So currently it looks like it's just falling through. So the pink ones are staying pink. Yes. So that means that my delta E calculations are incorrect. So you could assume equal power. So I could swap these in. There are multiple iterations that the color similarity equation has gone through. There's a simple distance based, but it didn't place the correct amount of weight on things like luminosity, where that factors in how sensitive to each color our eyes are when evaluating how similar colors are. So the simple kind of distance-based didn't factor that in. So I made some improvements, and the delta E 2000 is way more complex than basically just a Euclidean distance formula, and it might be enough to just do that instead. It's definitely cheaper, because it's a cheaper equation. So this section that has a little bit of blur in it, that color is evaluating us closer to the brown, which makes sense because you put those colors together, and that's what you get. So this is behaving more correctly. So we're going to do input color. This is going to be our image. And then I don't think this matters. Doesn't. So we're gonna make this 8 bits. I mean, we can make it 16, I guess. It'll be a 16-bit, 8-bit image. Let's save this. We have this palletize, which we don't need. We'll go in here, drag this pixelize, take our palette, do let's pipe this guy in, see what we get. All the colors in this are very, very similar. Hey, there you go. Cool. All right, so let's see if we can do something Minecrafty by just sampling and creating a palette from the image. So we'll kind of group our greens together. It's like this light green, medium green, darker green, a really dark green. And then grab some of the browns. This like light brown. It's kind of medium-ish brown. Darker, let's see, medium-ish. It's better. Too dark. Let's get one of the. There we go. And then it's really dark browns. Hey, that's kind of cool. We're seeing the some more of the info in here, like these colors. Starting to see those. This image doesn't have stone in it, so I'm gonna search for some Minecraft stone. Try to get image. Ooh, high-res textures. Okay, and then end of our brown, grab the lighter values. Oops, thank you. A medium-ish value, a darker value, and a really dark value. Then we'll grab some sky colors for the clouds. So these colors are pretty close. So sky blue, hazy horizon, the bottom of the cloud, and the top of the cloud. So there's our Minecraft palette. And this is what we get when we pixelize this. Hey, that's working. I'm surprised at the calc time on this. It's actually much lower than I thought it was going to be. So if we do, I don't know, Perlin noise, do I have any? So there's no like shape preservation. It's straight like value. So I guess it'd be on the artist to make sure that those things are the way they should be. So then here, if I do like subtract, wow. That's pretty cool. 512 is the max that you can go to on this. before it breaks, I think. Yep. And at that point, it's pretty expensive. It's, you know, putting in 1,000,000 pixels. Okay, so I was going to do like a... I'm just throwing together some like rocky soil with some green on the top of it. Oh. Not what is supposed to happen. So that is happening because of the column stuff. So the position is incorrect. Because I took this out. Oh, wait. I think it's not because of that. I mean, it might be, but I think it's because of tiling. It's not because of tiling. It's offset by 0.5. the that's why. So the sampling uses different coordinates than the pattern offset. That is good to know. Ah. So if I put this here, huh. So need any more color variation across the top. Or more value variation, but it's interesting that it's turning the rocks, pebbly bits, to the color that it is. It's pretty interesting. So we'll do subtract. I feel like it's going to take some getting used to. It's a bit odd, and I think this is where I need to fix my Delta E2000, that it's turning those areas green. Like if I just straight up pick this color, and it doesn't. Let's try higher frequency clouds. Yeah, that's kind of weird. Hmm. Hmm. Let's see if we can add some shadowing under this grass. Doesn't look like it. Dang, that's cool. I'm just looking at the screenshot, like the high-res texture. So I probably have to figure out a way to get like a better pixelization, because one of the issues that I'm noticing is that the detail that's in the texture map, because it's essentially random where that one pixel, that square in the FX map lands. We don't get any of the info from the surrounding areas, which is a shame. It's like overall this is fairly dark, and we have some of that coming through. But it would be nice to have a little bit more of that, like this noise that's happening in there. So let's crack a node open real quick. See if we can learn anything. So they're just doing a straight so well on it. So take the value, subtract that. The directional blur is useful. I'm just going to straight steal this. So that would go in here. So we need to do so this is adjusting the strength so that it corresponds to the correct pixel size. And then duplicate, switch this to X. And these are atomic nodes, so they're going to be faster than if we were to try to do that ourselves. So X and then Y. Oh! Dust Mittens! Thanks for the follow. and welcome. Okay, so then we're gonna sample the same location but in different images. So we're gonna sample in 2 and 3. And then we're just gonna average these. And then see if that just breaks everything apart. Shouldn't. So we're going to watch what changes here in the before after. Not too much, but we're going to keep it because it looks okay. So then if we wanted to fix this up a little bit more, we'd probably try to make the top a little bit lighter. So currently it only supports the limited palette. Currently it's just 16 colors. Extending it to support 256 might be a little difficult. Because currently what we're running is this for 16. And there's no way to like break out of the loop in programming terms. So we can't say, oh, if we get a delta E that's below 2, which I think is like imperceptibly small, then like stop calculating. So basically if the color matches more or less, then don't bother checking the rest of them. So I'm going to check to see what changing it to equal power does. It should stay sRGB probably. So yeah, that seems fine. 16 colors. Euclidean. Oh, I should put the weights in. But do that later. Tolerance. I can't find that number. I remember seeing it at some point, but I wonder if I can see, like, add more rocks. Lots of rocks. Hey, more rocks. That's so cool. What? It's covered with grass. That's very cool. Should I just give this thing like this? Just that. I gave this. It makes it look kind of like rock. Let's say I shift this. Into the sky. Color range. That's pretty cool. What's it called? Stylize. I'll try the forest ground. I don't feel so bad about the calculation time with these being, 390, 231. Let's go up. Whoa. So this has like quite a bit of detail and info in it, and this has similar the curves in Designer are weird. I just want to see if I can push most of the moss into the area that counts as green. So this is like almost all green. This is where you need to really simplify your forms to get them to read. Because this really awesome mossy forest ground is just a mess. And this really cool cliff rock. Is less. Still cool though. Pull the brown down so that we don't get it in on the rock as much. Ah, that's cool. What do these look like? Hot mess. Let's see, we could take the green down. More rock colored now. Turn them red. It's kind of crazy that the lines still show. Ah, that's so cool. Okay, cool. So, this is just a garbage graph, which I'm cool. I'm going to make this be the output of it and call it like demo palette. All right, so now we have a node. I can close these. I think I want to close this and just. Okay, so then we have this node where we can stick stuff in with our palette and then get stuff out. Great. Then pixel size. We could change the name of that to pixel number instead of pixel size. Yeah. Cool. Well, I think I'm going to call it. Thanks for hanging out and watching me do stupid math. There are a few things that I still want to work out. I may be able to get it to handle 256 colors, but a palette of 16 seems pretty good per thing. So for example, if you're doing this grass and dirt block, you probably wouldn't go above 16 for that. If you're doing a sand block, you probably wouldn't go above 16. This tree is like 4. But just because you have 16 colors doesn't mean you have to use them all. So I imagine you could stick something like this into the palette and you'd get something closer to this. So that way I could try working high-res procedurally and then chop it down to something that looks correct for a palletized game. So yeah, thanks again for hanging out, and we'll catch you guys on the next one.